Today we will discuss the part B experiment, stepper motor. So as the name says, this is a stepper motor which rotates in a stepwise direction. So this is the inner diagram of stepper motor. How does it looks? So you can see here it will be having 4 coils, which is called as A, B, A dash and B dash, or we can even call it as A, B, C, D. And the point is there will be a this particular motor, it will rotate in the stepwise direction. Just if the pointing direction is towards A, and then for the next pointing direction it will be moving towards B, so that will be around 90 degrees. Similarly again from B to A, one step, again A to B dash. So again this keeps on continuing, and it can rotate in anti-clockwise direction also. We can see the step here. Okay, you can see this table here. So this is for the full step rotation and this is for half step sequence. Full step in the sense, you can see here that whatever I have taken here A, B, A dash and B dash. So here I have considered it as 1A, 1B, 2A and 2B here. So you can see here this is full step rotation. If it has to rotate full step in the sense 1A to 2B it is rotating. So 1A and then till here. And then for the next sequence it should move from the next bit. Again the 1 is transferred here, you can see here, then it is shifted here. Similarly for the next cycle you can see here it is shifted. So this keeps on repeating until we provide the current for that. Similarly for the half step sequence, so what has to happen here is somewhere the pointing will be in between A and B here. So it is like one pointing towards A here and the other one in between. So for one particular step we require 2 rotations for the half sequence. So you can see here around 8 steps. See for here in the full step rotation we require 4 steps here. So if one full step has to complete in the sense 4 times, right? So it is like 1, 2, 3 and 4. But for half step it will be 8 because 1 here, 2, 3, 4, 5, 6, 7 and 8 finally. So that is what you can see here. So 1 and then it keeps on shifting as you can see in this table, and again it keeps on repeating. Let us see how this goes with the program. So the module name I have taken as a stepper, and the output, the pin number D out, clock and then reset bit and DR. Here DR, DIR, that stands for the direction. This D out is the output and clock and reset are used as an input here. So output you can see here as I have told 3:0 D out, and then input I have taken as clock, reset and the direction bit. So I have declared wire as the D out because we are using a behavioral model. And then even the register, this divider, this particular module, it is used for the clock divider. So we need the clock division because we are using FPGA kit. In that it cannot handle a high frequency, so we are supposed to divide that frequency for our stepper motor. In order for that we are using this division, clock divider here, in order to divide the frequency. And then we are using the shift register. This shift register, why we are using, because we need to shift this output, right? So that is why we will be using one variable called shift register in order to move the bits. So always at positive edge of the clock we will begin. If the clock is equal to 1 bit, then again the divide, whatever is the clock division is there, that will divide it and then we are going to add it. So that means every time we are going to add the bit here, and then similarly we will assign that clock division equal to this clock divide of 16, and always at negative reset or at the positive edge of the clock divider. So we are considering the clock division positive edge or at the negative of the reset. We are going to again assign reset equal to 1 tick bit 0, that is 0 bit, and then we are going to begin it. So now here the shift register, which will be assigning equal to 4 bit of 00001, that is 1 we are assigning the value for the shift register. And then if not the register is equal to 1 tick bit 0, then the clock division equal to 1 tick bit, and then the direction bit equal to 1 bit, and we are going to begin it and we are assigning the shift register value. So you can see here shift register of 0 and another one shift register of 3:0. That means, so first value we have 1 and the rest will be 000. That means again this value will be shifted and the rest value will be shifted like this. Just you can see here, one value will be shifted down, the rest 3 values will be shifted at the bottom. You can see here, right? So that is what we will be doing here, just using the truth table, whatever the table we have created, and using that we are writing this particular code. You can write any methods here, but we are just rotating the bit here so that it will be very easy. We are just shifting the bit here. And similarly for the next shift register, we are shifting the bit 2:0 and then shift register of 0. So that means we can rotate either in clockwise or in anti-clockwise based on this direction, and I will show that in the output. Okay. Similarly, let us go and see what happens in the program. I have already typed the program here and I have checked it. First here for the hardware programs, what we have to do is we need to check the syntax and then we will simulate it as done earlier. But along with that, you can see here something called as floor plan, right? So we need to click on this floor plan. You can see here. So in this floor plan, what we need to do is we are supposed to add the pin numbers for that. So in the FPGA kit we have lot of pins which will be used. So we need to assign the pin which we are using for our stepper motor. So we will be using for clock P79, for direction bit, that is to change the direction, P29, and these are the output pins P169, 175, 176 and 178, and then the reset bit is P21. So you can see here it is marked here. So this is how you need to assign the pin here, and after that we will come here. You need to configure the target device. Configure the target device in the sense we need to set the target device, that is the FPGA kit. So you can see here this is XC35 XC3S50, right? So this particular thing F02, that is the memory of our device, so we don't want that. We need to dump into the stepper motor bit here, right? So what we need to do is we just have to configure this particular thing, right? So and then we need to click on the program after configuring it, so the program is dumped into the kit. So let us see the kit here. Okay, I think you can see the particular FPGA kit. This is Spartan 3. I hope this is also visible. Okay, and these are the pin numbers which I have told I have assigned here, right? So this is the clock bit. Now it is 0, and if I need to on, I will on it like this. Fine. So you can see the light here. Okay, one thing, and this is the input which I am supplying, power supply for this particular thing. So using the power cable, and then I have used a JTAG bit. This is in order to dump the program, and this one I need the connection from this motherboard to the stepper motor. You can see here this is the stepper motor circuit which you can see here. Fine, and this is the stepper motor which I am using. Fine. So now my stepper motor is still off. So in order to turn it on, I need to turn on this bit. So let us see. You can check it out. The stepper motor is rotating. Fine. Now in order to change that rotation, I will turn on this particular pin number 3. Okay, you can see here. See the direction has changed. Okay, again I will show that to you. See. Okay, so using this pin number 3 here, I can change the direction of the stepper motor. You can even set the stepper motor directions, like you can reduce the step or you can increase the speed also, but it is not necessary to increase the speed and etc. here, because we need to know the steps here. But we can stop this particular stepper motor at 90 degree or whatever the degree we want. For each single step it is around 1.8 degree of step rotation is needed. So based on that we can calculate it. Okay, thank you.